Okay, today we are starting the class a little earlier. I will just share the slides. Is the screen visible? Okay. Welcome to the summary tutorials of the course Pericyclic Reactions and Organic Photochemistry by Professor A. Raman from IIT Madras. Myself Anisha Suresh, PMRF TF for this course from IIT Bombay. So, in the last 8 weeks, we have discussed different problems based on each week modules based on pericyclic reactions and organic photochemistry. So, in today's lecture, we will be discussing some important problems from each of the modules, which will be helpful for future exams as well as the coming exam for this course. Okay. So, now coming to question number one. The major product formed in the following reaction is. So here a cyclopentadiene and an alkene which is substituted by two ester groups have been given. So this is the electron deficient dienophile species and this is the diene. So as you can see, this is a 4 pi component and this is a 2 pi component. It will undergo a 4 plus 2 cycloaddition or a Diels-Alder reaction giving the product. So out of these four options, which will be the major product that is formed after 4 plus 2 cycloaddition reaction between these two substrates? Please take a minute for solving the answer. So since this dienophile is cis in nature, the product that will be formed will also be cis as the reaction is taking place through a concerted mechanism. Okay. And the important factor that we have to consider here is the endo rule of Diels-Alder reaction. So what will be the mechanism that is taking place here? So here this is our starting material. Okay. According to endo rule, for favoring the secondary orbital interaction, this dienophile will be approaching from below the plane of the diene. So the reaction will be taking place in such a way that the dienophile will be approaching from below the plane of the diene for secondary orbital interactions to take place, giving this as a major product. So the COCH3 will be coming below the plane. CO2CH3 will be coming below the plane, and here a double bond will be there in the diene fragment, diene part. So this will be the product and the hydrogens will be coming above the plane. So here endo rule is formed, and since alkene is cis in nature, it is maintained in the final product, alkene or the dienophile. Okay. Since the dienophile is cis in nature, it is maintained in the product, and here the both CO2 CH3 groups will be coming cis to each other. So the correct answer will be this is not true, as both the CO2 CH3 are coming trans to each other. So this will also be not true as it is exo approach. So option C will be the right answer. Here double bond will also be not there. So option C will be the right answer. So here a 4 plus 2 cycloaddition reaction or a Diels-Alder reaction is taking place between the diene component, which is a 4 pi component, and the dienophile, which is a 2 pi component. So since the dienophile or the 2 pi component is cis in nature, that cis nature of the substituents will be maintained in the product as well. And since it is having an electron withdrawing CO2 CH3 group, it will follow the endo rule of Diels-Alder reaction, and the dienophile will be approaching from below the plane such that the CO2 CH3 groups will be coming below the plane of the below the plane in the product. Is it clear? So this was a question from JAM 2018. So I will be discussing mostly questions that were asked in uh, this national level exams based on pericyclic reactions and organic photochemistry. Okay. So the right answer is option C. Now coming to question number 2. So this question number 2 was asked in JAM 2017. So the following conversion is an example of. So this is the starting material, and under heating condition it is converted into this product. So this conversion is an example of four options have been given. Is it an oxycop rearrangement, sigmatropic rearrangement, Claisen rearrangement, or pericyclic reaction? So for your understanding, this is an MSQ question, that is multiple select question. That so the more than one answer can be right in this question. Okay, so what is the mechanism or the conversion that is taking place here? So as you can see, this is an allyl vinyl ether. So it will undergo a Claisen rearrangement. Okay, so this Claisen rearrangement is also an example of 3,3 sigmatropic rearrangement, as you can see here. So this will undergo a 3,3 sigmatropic rearrangement, also known as Claisen rearrangement, leading to give this product. So what is happening here? So this bond is getting broken. So this Me Me will be here. A double bond will be forming here. Then a CH2. This CH2. After that again one CH2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, six membered system is this. So this will be the product that is found. So this, if we will redraw, it is similar to this one. And aldehyde is the CH2, CH2, then double bond Me. So this is an example of Claisen rearrangement, which is 833 sigmatropic rearrangement. So as we know, this 3,3 sigmatropic rearrangement is coming under pericyclic reaction. That is, the reaction will be taking place in a concerted fashion without the formation of any intermediates. Okay. So when we will be coming back to the options, so it is an example of sigmatropic rearrangement, that is right. It is an example of Claisen rearrangement, that is also right. And it is an example of pericyclic reaction, that is also right. So in the oxycop rearrangement, the oxygen will be coming outside the system. Like it is not a vinyl allyl ether system, rather than it will be like this sort of system where the oxycop rearrangement will be taking place. Okay, so this is not an example of oxycop rearrangement. So these three options are correct for the following conversion. So the right answer will be option B, C, and D. Any doubts? If there are no further doubts, we can move to question number 3. So this is a question based on Jablonski diagram that was asked in CSIR NET 2023. So I think we have seen the Jablonski diagram while we were discussing the introduction of organic photochemistry. So in the Jablonski diagram given below, the initial excitation take place from the singlet ground state to the second singlet excited state, that is S0 to S2. Match the processes to the events marked as A, B, and C. So here they have given this is the absorption that is taking place from S0 to S2. Then after that, from S2, it is coming back to S1 by non-radiative pathway that we have seen as internal conversion when we have seen Jablonski diagram. Now they are asking to find out what is this A. So here S1 to T2 non-radiative pathway, that is A. What is A? Then from T2 to T1 a radiative process is taking place, and from T1 to S0 another radiative process is taking place. So what is A, B and C? That is the question. So we know that from S1 state to T2 state, that is from one spin to another spin state, it is uh, converting, like it is undergoing a non-radiative process from S1 to T2. So this is an example of inter system crossing, which is a spin forbidden process. So A is an example of inter-system crossing. Then from T2 to T1, a radiative process, that is it is indicated by a straight line for radiative process, and for non-radiative process it will be indicating by a wavy line. So this is a non-radiative process. It is an example of inter-system crossing. Then T2 to T1, a radiative process is taking place. So this is an example of fluorescence. Okay, since there is no change in spin state and since it is a radiative process, it is an example of fluorescence. And from T1 to S0, the radiative process that is taking place is phosphorescence. Okay, so four options have been given, like A is internal conversion, B fluorescence, and C phosphorescence. That is not right. A is intersystem crossing, B is phosphorescence, C is phosphorescence. That is not right. A is internal conversion, B is phosphorescence, C is phosphorescence. That is also not right. A is intersystem crossing, that is right. B is fluorescence and C is phosphorescence. So option D is the right answer in this case. So for your reference, I have attached an example of Jablonski diagram here. So you can see here when this photons are excited with the light, when irradiated with light, this electrons will excite from the S0 state to higher excited states like S1 and S2. As you can see, that is the absorption that is indicated by this dark blue line. Then from S2 it can come to the S1 level by non-radiative pathway. This is known as internal conversion. So this one from S1 from a higher vibrational level of S1 to lower vibrational level, this is known as vibrational relaxation. Not from one electronic state to another electronic state, but from vibrational level of one electronic state to vibrational level of the same electronic state. If it is undergoing a non-radiative process, that is an example of vibrational relaxation. Okay, then from singlet singlet state to triplet state, if it is undergoing a non-radiative process, that is known as inter-system crossing. So this is the A that was given in our question, and here this is an example of vibrational relaxation. So here they have given from T1 to S0. So this is also an example of inter-system processing, not internal conversion. Then from T1 to S0, if it is following a radiative process, it is an example of phosphorescence. And from S1 to S0, when it is following a radiative process, it is an example of fluorescence. So this is Jablonski diagram. If you are having any doubts, you can ask regarding the Jablonski diagram. If there are no doubts, then option D is the right answer for this question. Okay. Now coming to question number 4. The mechanism for the formation of molecules A and B involved respectively. So this was a question that was asked in CSIR NET 2023. So this is the starting material. It is undergoing a direct photo irradiation. It will give a product B, and if it is undergoing a photo irradiation in the presence of a sensitizer, it will give the product A. So what is the mechanism that is involving in the formation of A and B? That is the question. So the options are oxidipymethane rearrangement and Norrish type 2 cleavage. Norrish type 1 cleavage and this is oxidipymethane rearrangement. And option C, oxidipymethane rearrangement and Norrish type 1 cleavage. And option 4, Norrish type 1 cleavage and Norrish type 2 cleavage. Okay, so this type of question was discussed while sir was discussing in the lectures. So as you can see here, this is our starting material. If it is undergoing a direct photo irradiation, it will give this product, and in the presence of a triplet sensitizer, it will result in the formation of this product. Okay, as you can see here. So evidence for involvement of the singlet n pi star state in alpha fragmentation and triplet pi star state in 1-2 rearrangement can be understood by seeing this uh, reactions. Okay, so what is taking place here? Under direct irradiation, an alpha fragmentation is taking place. Me, me, double bond O. So under direct irradiation, an alpha fragmentation will take place here. This arrow I will draw once again. Okay. So what will be the intermediate that is forming? Me, me dot and this carbonyl dot. I think I have forgotten to draw one CH2. Okay. Now what will happen? This tertiary radical, it will react with this um, alkene, leading to formation of a new alkene, and here a new radical will be generated. Double bond Me, Me, and here a new radical is getting generated. Now CH2, CH2, double bond O. So these two radicals they can recombine, leading to formation of a cyclobutanone ring. Me, Me. So this is how the first product is forming. Okay. So this is how product B is forming. So this is an example of nourish type 1 reaction. Now coming to this product, how it is forming, it is undergoing a oxadipymethane rearrangement. Oxadipymethane rearrangement. So how it is taking place? Under HNU and triplet sensitizer, this oxygen carbonyl will get excited, leading to formation of O radical and carbon radical. Then this carbon radical will react with the alkene, resulting in the formation of a cyclopropane ring. Okay, here a cyclopropane ring will be forming and oxygen radical will be there, and here a new radical will be there. Now what will happen? This carbonyl, when it is forming back, this bond will be breaking, leading to formation of a new radical there. Okay, here the carbonyl will be there, and here a tertiary radical and one another radical will be there that can recombine, leading to formation of our final product. So this is the final product that will be forming. That is A. So in the question, they were asking the mechanism for formation of molecules A and B involved respectively. So A involve an oxadipymethane rearrangement and B involve a Norrish type 1 cleavage. So option C is the right answer. Okay, is this clear? So direct irradiation, it will undergo an alpha fragmentation and then recombination, resulting in the formation of product B. And in the presence of a sensitizer, this oxygen like N to pi star pi to pi star excitation will be taking place, and a 1-2 rearrangement will be resulted. Okay, so option C is the right answer. Now coming to question number 5. The given reaction proceeds via. So these are the starting materials and this is the product that is formed. So this was also a question that was asked in CSIR NET 2023. So they are asking first it will undergo a 1,3 hydrogen shift followed by a 4 plus 2 cycloaddition, a 1,5 hydrogen shift followed by a 4 plus 2 cycloaddition, a 3 plus 2 cycloaddition followed by a hydrate shift, a 4 plus 2 cycloaddition followed by an alkyl shift. So what is the sequence of reaction and what are the reactions that are taking place here? Okay, let us see how this reaction is taking place. So as you can see, this was the starting material. So here you can number like 1, 2, 3, 4, 5. So if it will undergo a 1,5 hydrogen shift, this hydrogen if it is shifting like this, then what will be the, sorry, then what will be the uh, product that is resulting here? So here this hydrogen is shifting to here, so this double bond will shift here, and this the double bond will shift here, and this is the starting material that will be forming. So this is an ene component, diene, sorry, not ene, diene component. This is the, sorry, so this is the diene component, and here this is our dienophile. So it will undergo a 4 plus 2 cycloaddition reaction. Okay, so here a 6 membered ring will be forming, and here above it will be having a bridge like this. And since it will be following an endo approach, the hydrogens will be coming above the plane. So this is a 4 plus 2 cycloaddition, and here this is a 1,5 hydride shift. Okay, so in the option B is the right answer. First a 1,5 hydride shift will take place, followed by a 4 plus 2 cycloaddition reaction. Is it clear? So, this starting material will be undergoing a 1,5 hydrogen shift, resulting in the formation of the diene component for the Diels-Alder reaction to take place. Then it will undergo a 4 plus 2 cycloaddition reaction, resulting in the formation of the final product. So, the stereochemistry of this hydrogen, it is dictated by the endo rule of Diels-Alder reaction. Okay? Any doubts? So option B is the right answer for question number 5. If there are no further doubts in this question, let us move to question number 6. The following transformation is an example of 3 pi plus 2 pi cycloaddition, 6 pi plus 2 pi cycloaddition, 8 pi plus 2 pi cycloaddition, and 8 pi plus 4 pi cycloaddition. So these are the two starting materials that will react to give the final product. So this was a question that was asked in CSIR net June 2021. So this is an example of higher order cycloaddition reaction, a question based on higher order cycloaddition reaction. So here this system 1, 2, 3, 4. So it is involving an 8 pi component, and this will involve a 2 pi component. So this is an example of 8 pi plus 2 pi cycloaddition. Okay. Option C will be the right answer for this question number 6. So let us see how the reaction is taking place. So this benzene is the 2 pi component here. So here the cycloaddition will be taking place in this fashion. So the double bonds will shift like this way, resulting in the formation of Okay. So here the double bond will be shifting here. This double bond will be shifting here and double bond will be shifting here, resulting in the formation of the product. Okay, so this is the 8 pi component and this is the 2 pi component, and it will undergo an 8 pi plus 2 pi cycloaddition reaction, resulting in the formation of the final product. So option C is the right answer for question number 6. Clear? Now coming to question number 7. So here there was a mistake in the question. The correct answer will be like this: CHO and this. This is the final product. So this was a question that was asked in CSIR Net 2013. So the following reaction proceeds through A. So this is the starting material. Under thermal condition, it will give this as the final product. So what is the reaction that is taking place here? Either it is a 1,3 sigmatropic rearrangement, a 2,3 sigmatropic rearrangement, a 3,3 sigmatropic rearrangement, or a 3,5 sigmatropic rearrangement. So if you will closely observe the system, this is a vinyl allyl ether. So it will undergo a Claisen rearrangement, which is an example of 3,3 sigmatropic rearrangement. So option C will be the right answer for question number 7. So we will see how the mechanism is taking place in this case. Okay. So we can number the system like 3, 2, 1, 1, 2, 3. Okay, we can number the system like this. And for our convenience, we can number the 6-membered ring also, starting from oxygen: 1, 2, 3, 4, 5, 6, and this as 7, 8. So once it will undergo a 3,3 sigmatropic rearrangement, how will be it taking place? A reaction will be taking place in this fashion. A new bond will be formed between carbon 5 and 8, and this double bond will shift from carbon 7, 8 to carbon 2 and 7, and this 1 2 bond will be broken, leading to formation of an aldehyde. So if we will redraw this, how it will be? Just I will. Okay. So here a new bond is formed between carbon 8 and carbon 5, and here there will be a carbonyl. So this is a 1 2 3 4 5 6 6-membered ring. So I will number this. This is 5, 4, 3, 2, 7, 8. Okay, and this is 6, 1. Okay, so this is the product that you will get, and if you will redraw it, it will be like this: CHO double bond. So here the numbering will be like, on carbon 7 the methyl group is coming: 7, 2, 3, 4, 5, and this carbon is carbon number 6 and oxygen is 1. Okay, and this will be 8. So this is how the reaction is taking place. So this was our question. The following reaction proceeds through A. So this is the starting material and it is giving this as the final product. So it is undergoing a Claisen rearrangement, which is an example of 3,3 sigmatropic rearrangement. So option C, that is 3,3 sigmatropic rearrangement, is the right answer. So this was a question that was asked in CSIR net December 2013. Is it clear?
Yes, ma'am.
Okay. Now coming to question number 8. According to Frontier molecular orbital theory, the highest occupied molecular orbital HOMO of hexatriene in the following reaction is. So this is the hexatriene. Under photochemical irradiation, it is undergoing an electrocyclic ring closure, resulting in the formation of this cyclohexadiene. Okay, so they are asking so they have given the orbital picture and they are asking out of this which is the HOMO of hexatriene. So in the case of photochemical irradiation, what will be the HOMO of hexatriene? Like psi 1, psi 2, psi 3, psi 4, psi 5, psi 6 are there, out of which is the HOMO of hexatriene?
Psi 3 will be one.
Psi
Side 3.
Psi 3 will be HOMO in case of in normal case, okay? Like hexatriene will be having, just I will go to next slide, we will explain that. So hexatriene will be having total 6 electrons, right? It is having 6 electrons. So it will be distributed in psi 1, psi 2 and psi 3, like 2 to each. But upon photochemical irradiation from the psi 3, one of the electron will get excited and it will go to psi 4. Okay, psi 1, psi 2, psi 3, psi 4. So now the electron distribution will be like this. So under photochemical irradiation, the HOMO for cyclohexa means hexatriene will be psi 4. Highest
Yes,
occupied
thank you.
molecular orbital for hexatriene will be psi 4 in case of photochemical condition. When we are asking thermal condition, that time psi 3 will be the HOMO. But under photochemical condition, excitation is taking place and from psi 3, one of the electron is getting excited into psi 4. So the HOMO will be psi 4. Okay.
Yes, correct.
So if we will draw psi 4, it will be having 3 nodes, right?
Yes,
Psi 4
three
will
nodes.
have 3 nodes. So we can mark like this. So here the 3 nodes will be coming. So this will be the psi 4. So if you will see the options, these are the options that have been given. Here you can see the node is coming at these two positions. So two nodes are there. So this is not the answer. Here
Option number 4.
one node is there. So this is also not the right answer. Here two nodes are there. So this is not also the right answer. So here as we have seen, 1, 2, 3. 3 nodes are there and this is the psi 4 which is the HOMO for hexatriene in this photochemical condition. Clear?
Yes, clear.
Yes, ma'am.
Okay. So this was a question that was asked in CSIR net December 2017. So option 4 is the right answer. Now coming to question number 9. Major product obtained in the following reaction is. So these are the two starting materials. So this actually you cannot draw like this, it will be a linear mold. Okay, it should be drawn like this. So the major product observed in the following reaction is, so these are the two starting materials and it will react and give product. So what is the reaction that it is undergoing here?
Diamsalder.
So it is undergoing a Diels-Alder reaction. So we have learned regarding the regiochemistry of Diels-Alder reaction, right? So since this amine is an electron donating group by resonance effect, this sender will be electron rich sender. And this CH3, since it is an electron releasing group by inductive effect, this will also be an electron rich sender. These both senders are electron rich senders. Okay. So when the reaction is taking place, it will take place in such a way that electron deficient sender and electron rich sender will be reacting. So the reaction will be taking place in this fashion. So this is electron rich sender. So here this will be the electron deficient sender. Here this is the electron rich sender and here this will be the electron deficient sender. So Diels-Alder reaction it will be undergoing. I will draw the arrow in other way around. So the Diels-Alder reaction will be taking place in this manner. And we will get CH3, OCH3 and NH2. This as the major product. So option A will be the right answer for this question. So here they are asking for regiochemistry in Diels-Alder reaction. OCH3 and triple bond CH3. So these are the two starting materials. So this is an electron releasing group by resonance effect NH2, right? So because of that, at this sender it will be more electron rich. So this is an electron rich sender. And here this CH3 is electron releasing by inductive effect. So this sender will be electron rich sender. Okay. So since these two are electron rich senders, so the reaction will be taking place in the other direction. So the reaction will take place in this fashion. Okay, so this is electron rich sender. This will be electron deficient in this case. So it will attack here. And this is the electron rich sender here that will go and attack here. And it will result in the formation of the Diels-Alder product. Is how regiochemistry is coming clear?
Yes, ma'am.
Okay.
Yes, ma'am.
So option A is the right answer in question number 9. Now coming to question number 10. The diene and dienophile that can be employed to synthesize norbornadiene isor R. So this is the structure of norbornadiene. So here this is the product they are asking. Out of these four options, which starting materials will be giving this product norbornadiene?
Option A.
Option A will be the right answer. So we can see here, this is a cyclopentadiene, and in the presence of an alkyne, a Diels-Alder reaction can take place. So this is the diene component, this is the dienophile component, and this is the diene part, and the dienophile part will be coming here. So a double bond will be remaining here and a new double bond will be forming here. So Norborna diene is resulted when these two starting materials are reacting. When we will consider the other cases, in this case, when a Diels-Alder reaction will take place, the product that will be formed is norbornene, not norbornadiene. Okay. So in case of B, we will be getting this as a product. And in the case of C, we are having this butadiene plus ethylene. It will undergo a classical Diels-Alder reaction resulting in the formation of cyclohexene. And in the other case, this butadiene and this substituted ethylene, it will undergo Diels-Alder reaction resulting in the formation of the substituted cyclohexene. Clear? So option A is the right answer. These two starting materials, that is cyclopentadiene and ethine, they will undergo a Diels-Alder reaction resulting in the formation of norbornadiene. Clear?
Yes, clear.
Okay. So option A is the right answer. Now coming to question number 11. Major product formed in the following reaction is.
Option 1.
Option, option 3.
Option 3 will be the right answer. So this is a system that will undergo an oxycope rearrangement. So 3, 2, 1, 1, 2, 3. So it will undergo an oxycope rearrangement resulting in the formation of, I will draw here. So it will undergo a 3, 2, 1, 1, 2, 3 oxycope rearrangement resulting in the formation of this intermediate. Okay, the double bond will be shifting here. This new double bond will be forming here, and this OH will be here. And stereochemistry of hydrogen will not be important as now it is an alkene. Now here this can undergo a tautomerism resulting in the formation of a ketone here, and the double bond will be here. Okay. So this is an example of oxycope rearrangement. So option 3 will be the right answer. Is it clear?
Yes, ma'am.
Okay. Now coming to the next question. The final product formed in the below reaction will be. So this is the starting materials, and under thermal condition it will be undergoing some reaction giving one of this as a major product. So what is the product, final product that is formed in this reaction? So please try to work it out.
Option B.
Like it,
Option D.
option actually the right answer will be option A, because here this B will be forming but it will be an intermediate. Since this system it can undergo a chelotropic elimination like this fashion. a removal of ethylene molecule will be taking place, resulting in the formation of this aromatic compound. So that regaining of aromaticity is the driving force for giving this as the final product. Okay.
Yes, okay, ma'am.
So first it will be undergoing a 4 plus 2 cycloaddition. So this is the diene and this is the dienophile. So it will undergo a 4 plus 2 cycloaddition like this fashion, resulting in the formation of this product. Okay. Now this can undergo a chelotropic elimination of ethylene molecule. So minus CH2 double bond CH2 will take place and it will result in the formation of this as the final product. Is it clear?
Yes, ma'am.
So option A is the right answer. Now moving to question number 13. Draw the structure of the chief product of each of the following thermal reaction. So this is our starting material and under thermal condition it will give the product. So this is an example of electrocyclic ring closing reaction. Okay. So what will be the major product that is forming here? So please tell me it is foreign system or foreign plus 2 system. It will undergo conrotatory or disrotatory mode of ring closure.
First, it is a 4n plus 2 system and it will go this rotation
Foreign
under thermal condition.
4n plus 2 system. So this is thermal condition. It will undergo
This rotation.
this rotation. Right. So under this rotation, so this closing will be taking place in this fashion. So this when it is moving in clockwise fashion, the CH3 will be coming above the plane, and when it is moving in anti-clockwise fashion, this hydrogen will be coming above the plane. So a trans product we will be getting. Okay.
Yes, ma'am.
So here this will be hydrogen will be above the plane in this case and CH3 will be above the plane in this case. So whenever we are seeing an electrocyclic reaction, we have to think about the Woodward-Hoffmann rules. 4n delta conrotation, 4n H nu disrotation, 4n plus 2 delta disrotation, and 4n plus 2 H nu conrotation. So this we have to keep in mind while solving any questions based on electrocyclic ring closure or ring opening. Okay.
Yes, ma'am.
So as you can see, system has 4n plus 2 pi electrons. Its HOMO in thermal condition is Psi3, which has mirror plane symmetry. Therefore, motion will be disrotatory. So under disrotation condition only, this constructive overlap will be taking place, resulting in the formation of this trans product. Okay. So here they are explaining based on the FMO. So this plus plus overlap should take place. So for that overlap to take place, the orbitals have to come like in this rotatory manner. Now coming to question number 14. Complete the following reaction. So what will be the reactions that are taking place here?
First elimination of SO2, then we will get a diene.
Hmm.
The diene will react with the dienophile.
Yeah. So this is undergoing a two-step process. One is a chelotropic elimination, resulting in removal of SO2, and second, a 4 plus 2 cycloaddition reaction. Okay. So as you can see, first a chelotropic elimination reaction will be taking place where SO2 will be removed and we will get this diene. This diene can undergo a 4 plus 2 cycloaddition reaction with this dienophile CO2CH3, and here secondary orbital overlapping we can consider. So it will follow an endo rule, and hence the product that will be formed will be CO2CH3. So here the stereochemistry of the hydrogens will be above the plane and this will be below the plane. Okay. So this is how the reaction is taking place. So first we have to eliminate one molecule of SO2 so as to generate the diene. So this is the key step, followed by a 4 plus 2 cycloaddition reaction resulting in the formation of the final product. Clear?
Yes, ma'am. Clear.
Okay. Now coming to question number 15. Complete the following reactions. So what is the reactions that is taking place here? So this is also delta, okay?
First one, it will undergo 3 plus 3 sigma tropic.
Yeah. So you can see this is a vinyl allyl ether. So vinyl allyl ether, it can undergo a 3,3 sigma tropic rearrangement, that is a Claisen rearrangement. If we specifically telling, it will undergo a Claisen rearrangement. So if we will draw, it will be like this. Okay. This if we will redraw, it will be like this. So it will undergo 3 2 1 1 2 3, a Claisen rearrangement resulting in the formation of here CH2 double bond O. One CH2 will be coming here and double bond O. So this will be the product that is formed after this 3,3 sigma tropic rearrangement or the Claisen rearrangement. Clear?
Yes, ma'am. Clear.
So in second case also it is similar. So
Yes,
this
3
is the
plus 3.
vinyl component and this is the allyl component. So this will undergo a Claisen rearrangement. So we can number it like 3, 2, 1, 1, 2, 3. Okay. So the reaction will be taking place in this manner, and the product that will be formed is, so here a new double bond is forming between these two carbons. This group is entirely shifting to this side. So a CH2 aldehyde. Okay, this will be the final product that is formed in this reaction. So both these are examples of Claisen rearrangement, which is a part of 3,3 sigmatropic rearrangement. So for identifying if it is a Claisen rearrangement, then the system should be having an allyl vinyl ether. Okay. So this is the explanation. The substrate is allyl vinyl ether. Therefore, the reaction will be a Claisen rearrangement. So it will undergo a 3-2-1, 1-2-3 Claisen rearrangement, resulting in the formation of this as the final product. In other case also, the substrate is allyl vinyl ether. Therefore, the reaction is aliphatic Claisen rearrangement. So here also a 3-2-1, 1-2-3 Claisen rearrangement will take place. So this whole group is getting shifted to this position. So this is the final product that is forming. Clear?
Yes, ma'am.
Okay. Now coming to the next question. Predict the product of the following reaction. So what sort of reaction is taking place here?
Ring closer.
Yeah. This is an example of electrocyclic ring closing reaction. Okay. So like this system is 4n system or 4n plus 2 system?
4n plus 2.
Furan.
It like 1 2 3 4 5 6 12 electrons are,
4n.
so it is an example of foreign system. Okay, so foreign system under thermal condition it will undergo,
Con rotation.
yeah, foreign system under thermal condition it will undergo conrotatory mode of ring closer. Okay, so the reaction will be taking place like in this fashion, all the electrons will be involved. Hmm? And the final product that will be forming will be, here a double bond will be there. Okay, then the hydrogen stereochemistry, so it will be coming trans, right? In conrotation the stereochemistry will be trans. If we are considering, one will be rotating in this direction, the other will be rotate, one if it will be going above, the other will be going down. So here if you are considering two hydrogen, once it is undergoing conrotation, this can go down and this will be going above. Okay,
Yes, ma'am.
so the final product formed will be trans in case of the electrocyclic ring closing mechanism. So a 12 electron conrotatory electrocyclic ring closer gives a trans tricyclic product. The 12 electron electrocyclic ring closure of a very long pi system is feasible here as 4 pi bonds are constrained in two rings when the two ends of the pi system can come closer in the essence conformation of the diene units outside the rings. So this conformation, this ss conformation is bringing these two units together so that it can undergo this 12 electron electrocyclic ring closure reaction. Okay, so it will undergo a conrotatory mode of ring closure resulting in the formation of this trans product. Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Okay. Now coming to the next question. Complete the following reaction. So here an alkene is given and another alkene is given. So what sort of reaction it is undergoing? Please try to work it out.
This is a Ain reaction.
Yeah, this is an example of ene reaction. So how it is undergoing? So this is the ene component and this is the enophile component. Ene, enophile. So here the hydrogen from the ene is transferred to the enophile and this double bond will go and attack on the alkene, resulting in the formation of this as the final product. So is it clear how the reaction
Yes, ma'am.
will take place?
Yes, I got the same answer.
Okay. So this was an example of ene reaction. Now coming to the next question. Identify A, B and C in the given reaction sequence. So this is the starting material. It is treated with this uh, thiophenyl chloride in the presence of pyridine, giving an intermediate A, which upon treatment with pyridine will give B, and that will undergo a thermal reaction giving C. So please try to work it out. Did you get?
Ma'am, is it a 2 plus 3 sigma tropic?
Yeah. So first, this alcohol will attack on this sulfur, leading to removal of Cl, that is a substitution nucleophilic reaction will be taking place, and in the presence of pyridine this H plus will be removed, giving the B, which is CH2O S pH. Okay, So this will be B and A will be this one. Fine. Now this can undergo a 2 3 sigmatropic rearrangement. So the numbering will be 3 2 1 1 2. So it will undergo a 2 3 sigmatropic shift, resulting in the formation of this as the final product. So this alcohol, it will react with the sulfur, removing the Cl minus, resulting in the formation of A, which is an example of substitution nucleophilic reaction. And in the presence of pyridine as the base, the pyridine will be abstracting this proton, resulting in the formation of B. So this substrate can undergo a 2 3 sigmatropic shift under thermal condition. So this is 3 2 1 1 2. So it will be undergoing a 2 3 sigmatropic shift, as you can see here by the arrow pushing, and it will give C as the final product. Is this the same that you got?
Yes, ma'am.
Okay. So this is clear, right?
Yes, it is clear.
Okay. Now moving to question number 19. Give product and stereochemistry of the product in each case. So these two reactions are example of what sort of reaction?
Dipymethane rearrangement.
It's not dipymethane rearrangement. So this is an example of electrocyclic ring closing reaction only, but in a cation is present in between the system. Okay.
Yes, ma'am.
So this system, is it a foreign or foreign plus 2 system?
4N system.
This is a foreign system, and
Foreign.
condition is thermal condition. So foreign delta, it will undergo conrotation. Similar is the case with this also, foreign delta conrotation. So please try to draw the product.
A will be cyclopentene system with both the CH3 in opposite phase trans.
Okay.
Yes, like this.
Hmm. So here, as you can see, this is foreign system and it will undergo conrotation. So when conrotation, it will be like same direction. So this CH3 which is outside, it will go above the plane, and this CH3 which is outside will be coming below the plane while rotating in the same direction. In this case, one CH3 is inside and other CH3 is outside. So here when we will do conrotation, the CH3 will go below the plane and the other CH3 will also be going below the plane. So we will be getting cis product. This is giving trans product. This is giving cis product. So here conrotation is taking place in both the cases. Okay. So such if anions will be coming, then the electrons involved will be different. Then it will be 4n plus 2. But in the case of cations, here it will be 4n system. Okay.
Yes, ma'am.
Yes, ma'am.
Okay. Now we will go to last question of today's session. Give product in the following reaction. So here we are having a acid and an alkyne. So what sort of reaction is probably taking place here?
We will get a five-membered ring containing three nitrogens in that ring.
Mm-hmm. So it is an example of 1,3 dipolar cycloaddition,
Yes, yes. 1,3 type.
1,3 dipolar cycloaddition, or we can tell like 3 plus 2 cycloaddition. Okay. So this aside, it can be written like C6H5N like this, negative, positive. So this can react with this alkyne. It will undergo a 1,3 dipolar cycloaddition reaction as you can see here. So here some mistake is there. This cannot be written like in this fashion. So if it is coming here, it will be like C6H5 N minus N triple bond N plus. Okay. So the reaction will be taking place like N triple bond N minus C6H5 C triple bond C CO2 Me CO2 Me. So the attack will be taking place in this fashion, resulting in the formation of CO2 Me. Clear? So this is an example of 1,3 dipolar cycloaddition reaction. Is this clear?
Yes, ma'am.
So I think we have discussed. I have tried to cover all the parts that were discussed from week 1 to week 8, including electrocyclic reaction, cycloaddition reaction, like 4 plus 2 cycloaddition, 1,3 dipolar cycloaddition, then ene reaction, chelotropic reaction, and some organic photochemistry questions as well. So, do you have any doubt regarding the questions that we have discussed today? Actually, I started a little early today. I started around 4:30.
That's why I missed that photochemistry, that part that I wanted to
Okay.
attend.
Okay. I will go back to. I have discussed few questions only, maybe based on that part, because last two lectures we were discussing the same now. So these two were some questions based on these two questions only from based on organic photochemistry. question 3 and 4. I will repeat once again, okay?
Okay.
So here in this question, the Jablonski diagram is given and they are asking the initial excitation takes place from the singlet ground state to the second singlet excited state, that is S0 to S2. Match the processes to the events marked as A, B and C. So they have given that the excitation is taking place from S0 to S2. Okay, and they have marked this as A, this as B and this as C. So we have seen the Jablonski diagram when coming from like non-radiative pathway from higher excited state to like lower excited state, lower electronic states. When it is coming non-radiative pathway, that is known as internal conversion, right? And when it is in the same vibrational levels, it is known as vibrational relaxation without changing the electronic state. And from a singlet state to triplet state, when it is undergoing a non-radiative pathway, that is known as inter-system crossing. So this A will be inter-system crossing. And they have shown a radiative pathway from T2 to T1. So we have seen fluorescence mostly from singlet S1 to S0, but this is also an example of fluorescence, as there is no change in the spin state. Okay.
Okay, ma'am.
So B will be an example of fluorescence. Now they see they have marked from T1 to S0, right? So T1 to S0 radiative process, that is known as phosphorescence. So out of this four options, option D will be the right answer. That is first intersystem crossing, that is from S1 to T2 non-radiative pathway intersystem crossing. B is fluorescence, that is a radiative process from T2 to T1. So this is fluorescent. And C, that is radiative process from T1 to S0. It is an example of phosphorescence. So I have just given this Jablonski diagram for better understanding. So first absorption will be taking place from S0 to higher excited states like S2, S1, etc. So from S2 to S1 non-radiative process, that is internal conversion. So here from the higher vibrational state of S1 to lower vibrational state of S1, that non-radiative pathway is known as vibrational relaxation. And when a non-radiative transition is taking place from S1 to T1, that is known as inter-system crossing. So here they have mentioned like from T1 to S0. So this is most probably in inter-system crossing only. Okay, that is mistaken. Inter-system crossing. As there is a change in the spin state, it is known as inter-system crossing. Now, from S1 to S0 radiative pathway, it is known as fluorescence, and from T1 to S0, the radiative process is known as phosphorescence. So, if higher levels of T2 is given, and from that, if radiative process is taking place, that is also an example of fluorescence. So, problems based on Jablonski diagram can be asked if organic photochemistry, introductory or organic photochemistry questions will be asked, like Jablonski diagram is important. Now coming to question number 4. So here they are asking the mechanism for formation of molecule A and B involved respectively. So this is the starting material. Under direct irradiation, that is without the presence of a sensitizer, it is giving the product B. And this starting material upon irradiation in the presence of a triplet sensitizer, it is giving this product A. So they are asking what is the mechanisms that is involved in the formation of A and B. Okay, so different examples have been given like oxide hypomethane rearrangement, Norrish type 2 and type 1 reactions. So the right answer will be here, an oxide hypomethane rearrangement will be taking place, and here a Norrish type 1 reaction is taking place, that is alpha fragmentation is taking place. So this question was discussed in the lecture as well. So here they have shown that under direct irradiation, this is giving this cyclobutanones, product, and in the presence of a triplet sensitizer, this rearranged product is resulted. So res- this results are giving an evidence for involvement of a singlet n pi star state in alpha fragmentation and a triplet pi star state in 1,2 rearrangement. So here oxidipymethane rearrangement is taking place, and here an alpha fragmentation is taking place. So alpha fragmentation, as we have seen, it is a pathway involved in Norrish type 1 reaction. Okay, so here how the reaction mechanism is taking place. First, an alpha fragmentation will take place, result in the formation of this carbonyl radical and this triplet radical. Then this alkene, uh, this will rearrange in this fashion, like so here a new radical will be generated, and this new radical will recombine with this tertiary radical, resulting in the formation of a new alkene. And this new radical, it can recombine with the carbonyl radical, resulting in the formation of a cyclobutanone. So this is the primary process that is taking place in the Norrish type 1 reaction, that is the alpha fragmentation. And after that, whatever taking place as secondary process, and the final product that will be resulted is B. So this is B. So here a Norrish type 1 reaction is taking place. Okay. And in the second case, the product that is formed is this one. So how it is taking place? It is undergoing a oxidipymethane rearrangement. So in the presence of a triplet sensitizer, this carbonyl is getting excited and it will form oxygen radical and a carbon radical. Then that carbon radical can react with this alkene, resulting in the formation of a cyclopropane, and here a new radical will be generated. Okay, now when this carbonyl is forming again, this bond, this bond of the cyclopropane will break, resulting in the formation of a tertiary radical here, and the carbonyl will be regenerated, giving this intermediate. Now this tertiary radical and this radical which is already present in the system, they will recombine, resulting in the formation of a new cyclopropane ring. So here a 5 membered, 6 membered fused with a three membered ring is formed. So this is how this product is resulted. So from this, A will be formed by a oxidipymethane rearrangement of the starting material, and B will be formed by an alpha fragmentation followed by some secondary processes, that is Norrish type 1 cleavage. Clear?
Yes, ma'am.
Yes, ma'am.
Okay. So this was all about organic photochemistry questions. Remaining questions, any doubt is there?
No, ma'am.
Okay.
Ma'am, one thing I just wanted to ask, like in our examination,
Hmm.
it is a like computer based, but it is a offline. We have to write and we have to submit our booklets.
Okay. Yeah.
So in that, what kind of questions will get objective or subjective?
Mostly subjective. I think your assignment questions are subjective, right? So there is
Yes.
chances that it will be mostly subjective.
Okay. Ma'am, one more thing. Assignments, like who is correcting our assignments? Like suppose I want to check my assignment 5 because there I got less marks. But according to when I checked the solutions, almost I found that it was correct. Whatever I just written there, it was almost correct. But why I lost marks that I wanted to check. So,
Actually, I am not correcting.
okay. So can I get my that corrected one assignment like in mail or something so that I can check?
They will be sending solutions to you, na? So you can compare it with that. It will be uploaded in that portal only. Solutions.
Solutions I checked, ma'am, but the thing is what where I am losing the marks that I wanted to check.
That actually I have no access to that.
Okay, okay, no problem, ma'am.
Hmm.
Thank you.
Okay. So, if there are no further doubts, thank you for attending today's session and all the best for your final exams. When is your exams coming?
Next Saturday,
20,
20.
22 March.
Okay, all the best.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Thank you. I am just